Part 3, Applications of Linear Equations in 3 Variables. Find the quadratic function f of x equals ax squared plus bx plus c, passing through the points 2, 3, negative 4, 39, and 5, 12. So I have 3 points that I know this quadratic passes through. So I need each of these 3 points to work in my quadratic function. So I'm going to set up 3 equations with these 3 points. So the first equation, I'll use x is 2 and y is 3. So I have 3 equals a times 2 squared plus b times 2 plus c. So this equation is 4a plus 2b plus c equals 3. Then I'll do the same for the next point. So y is 39, and I have a times negative 4 squared plus b times negative 4 plus c. So this equation, negative 4 squared is 16, so I have 16a minus 4b plus c equals 39. And then for the last point, when y is 12, x is 5. So I have 12 equals a times 5 squared plus b times 5 plus c. So this equation looks like 25a plus 5b plus c equals 12. And here's my system of equations. Now I have 3 equations, 3 unknowns. I need to solve for a, b, and c. I'm going to eliminate c. So I'm going to pair the first 2 equations and then the second 2 and eliminate the c. So in the first 2 equations, I'll keep that second equation like it is and multiply that first equation by negative 1. So I have negative 4a minus 2b minus c equals negative 3. And then when I add 16 plus negative 4a is 12a minus 6b, 0c, and then equals 36. So there's one equation. Now I'm going to do the same thing with the second 2 equations that I paired. So the third equation I'll write like it is. And the second equation I'll multiply by negative 1. If I add these 2 equations, I can eliminate c again. So 25a minus 6a, 16a is 9a. So I have 9a plus 9b equals 12 plus negative 39 is negative 27. Now I'm going to notice, just to make this easier, smaller numbers make everything easier. On this equation right over here, I can divide both sides by 6, just to have a simpler equation. If I divide both sides by 6, I get 2a minus b equals 6. And for this equation over here, if I divide both sides by 9, then I have simpler numbers again. So I divide both sides by 9, and I get a plus b equals negative 3. So now I need to solve this system of equations to find a and b, and then I can go back and plug those in to one of the original equations to find c. So notice if I just add these 2 equations together, I can eliminate b. So I have 3a equals 3, divide both sides by 3, and I get a equals 1. I'm going to substitute that back into here. So I have a is 1, so 1 plus b equals negative 3. Subtract 1 from both sides, and I get b equals negative 4. And then I'm going to substitute both of those into one of my original equations. I'll use the top equation up here. So 4 times a plus 2 times b plus c equals 3. So I have 4 minus 8 plus c equals 3, or negative 4 plus c equals 3. Add 4 to both sides, and I have c equals 7. So I've solved my equations, my system of equation. Now I need to write my quadratic formula. So my quadratic formula I'm looking for is f of x equals ax squared. A is 1, so 1x squared plus bx, but b is negative 4. So negative 4x plus c, and c is 7. So this is the quadratic equation we were looking for.